Hello everyone. So today we are going to learn about the cluster analysis. So I think this is one of the very important type of analysis which we do in most of the quantitative analysis part during data analysis for any project or research. So let's see. Let's try to understand about the cluster analysis. So in general, it is nothing but a cluster is nothing but a collection of data objects which is similar to one another within the same cluster. That means elements within the same cluster have same properties. Whereas on the other hand, there are different objects which are different in different clusters. So these are dissimilar to the objects in other clusters. So elements in one cluster are different from elements in other cluster. So now when you are trying to understand about the cluster analysis, it means finding similarities between data according to the characteristics which are found in the data and grouping similar objects, maybe with certain attributes in one cluster, and those clusters are different from other clusters. We also conduct unsupervised learnings. So there are technically no predefined classes. So we have to define the classes, and then at the end we have to find the best possible clusters. So there are typical applications which are there. As it can be a standalone tool to get insight into the different kind of objects which we see in data distribution. It can also be used as a pre-processing step for other algorithms, which can come later. So there are different types of applications and multidisciplinary efforts which are there in clustering. So first we can see there is a pattern recognition. So this is something typical in every cluster. So first we have to identify patterns according to which we will group the clusters, and we will separate those clusters from other clusters. Spatial data analysis can also be performed, where we can see that we can create different kind of thematic maps in GIS, geographical information system, by clustering feature, and we can create spaces among them. So we can separate one geographic location from another geographic location. So this spatial data analysis can be used there. It can also be used to detect spatial clusters which are far from one other geographical location, or it can also help in mining of those spatial locations or tasks. Image processing, it can also be used in terms of image processing. So we see that many times we get confused between two similar kind of images, but if we use this clustering method, we can find out that one image is different from another on the basis of certain characteristics, which can be the facial part of a person, or it can be in terms of the other dimensions or physical dimensions. It can be used in the form of economic sciences also, especially in marketing research, when we try to evaluate different kind of economic demand or supply based patterns. It can also be used in terms of websites, that is how we understand that one website is the real website and another website is not real website. It can be done using document classification, that is what kind of documents are there in websites, and based on this we can try to find out that which websites are real and which are fake. It can also be used to find out what kind of web logs are there according to different websites, and based on those patterns and how they have been accessed, we can also find out that whether there is a real-time application of that particular website. So some of the examples of clustering applications we can see in terms of marketing, land use, insurance, city planning, earthquake studies. In marketing, it is very common that in terms of different customer bases, we need to separate different types of customer groups on the basis of age group, or on the basis of geographical locations, or on the basis of other demographic features. So there also we can use this clustering approach. In terms of land usage also, even we can segment different types of urban, rural, semi-urban, or semi-rural based typical locations in different parts of the earth. It can also be used in insurance sector, where we can use this in terms of allotting different kind of premiums for different motor insurance policy holders. Again, the claims and all these things can also be measured up using this clustering applications. In case of city planning also, city development also, like which part of the city has to be developed first, and what kind of different kind of houses are there. There are different attributes, such as you can see the house types, house values, geographical location. This city planning can also be performed. Earthquake studies, mainly in case of disaster management techniques, we can use that in which part of a certain location we have this epicenters of earthquake, and how it can be uh, studied for a given period of time, so that we can find that where are the major faults and how it can be avoided. So let's try to understand what is quality. So what is good clustering? This is very important question. So generally you will see a good clustering will have two important features. Number one is it should have high interclass similarity, that is objects within the same class are similar, very much similar to each other, very less differences. And on the other hand, it should also have low interclass similarity, that is two different clusters cannot have similar objects in those clusters. So that means an element or object in cluster A should not be similar to another object or element in cluster B. So it should have less similarity as possible between objects of different clusters. So these two are the important qualities. Beside this, it also depends on what kind of measurement we are taking and what kind of methods we are using, and the real-time application or implementation part is also important. It depends on case-to-case basis. The quality of a clustering method, it is also measured by the ability to discover some or all of the hidden patterns. Many a time we discover some hidden patterns, like in marketing also, when we start with one application like sales, after doing a lot of different kind of algorithms we will see later. So we find that there are certain emerging patterns which might be entirely different from what we understood in the beginning, like expenditure results of customers, or spending habits of customers. So some different kind of patterns may also emerge. Then we can also use different kind of measurement techniques in clustering. We can see the dissimilarity and similarity part. So it is expressed in terms of distance function, that is typically in the form of dij, which is distance between 2 points I and j. So this is a separate quality function that measures how good cluster is, or the goodness of a cluster can be understood. So the definitions of distance functions are usually they're based on different things, like it can be based on interval scale or a Boolean scale or categorical scale, or it can be in form of ordinal ratio and vector variables. Weight should be associated with different variables. Again, it is based on the application that different elements are there in a given function. Like in a given function y, we have three elements a, b, c. So how much weight we are going to give to a? Maybe 80%, maybe 10% to b, maybe remaining 10% to c. So again, it depends upon the application part. It is hard to define similar enough or good enough, because many times we see that what kind of weight we have assigned in one application might be entirely different when it is implemented in another scenario. What are the requirements of clustering in data mining? It can be used in terms of scalability. As I said, comparability and in terms of measurements can also be very important feature. It can also have the ability to deal with different types of attributes in different kind of applications, marketing, or maybe HR applications, or in real-time kind of engineering applications or implementation scales. You will see different types of attributes can be there. So clustering can include all those attributes put together on a different level or in a different scale. It can also be able to handle dynamic data which is varying continuously. So a good cluster technique should also involve this ability to handle this continuously changing data. So it can also help in discovery of clusters with arbitrary shape. Different shapes can be there, we will see later. Minimum requirements for domain knowledge to determine input parameters. So if you understand the input parameters, that is 6 to 7 input parameters should be there. So we can also understand that how this parameters can be used, and you don't need to have too much in-depth knowledge. If you understand the parameters and if you can find the patterns, you can actually go on making different types of patterns and finding the interrelationship among certain variables. It can also, it should have the ability to deal with noise and outliers. There are certain points in a given data sheet where you will find certain points which are outliers and which may not be able to define the clusters properly. So a good clustering algorithm should be able to identify which are the outliers, which are the noises, which should be separated so that you can find the right pattern of creating a cluster. So it should be insensitive to order of input records. So in whichever order, like if you are inputting 1, 2, 3, 4, 5, 6, and even if it is inputted in the times of 4, 5, 6, 3, 2, 1, something like this. So there also the result should not vary. So a good clustering algorithm should have that quality. It should have high dimensionality. So more and more inputs can be there. So that dimension possibility should be there, increase in dimension possibility. It should also be able to incorporate different user specified constraints. It should also have a different kind of interpretability. As I mentioned, different interpretation, different implementation, and of course, usability in different types of applications. Data structures can be of two types. So generally you have data in two formats, either in the form of data matrix or dissimilarity matrix. So in data matrix, you will see as we are inputting the data sheet can be have this certain kind of inputs. These are simple data matrix on the basis of input pattern. You can also have dissimilarity pattern, that which data are not similar to each other. You can also put them together. So this is on the basis of one mode. So you can see that there are certain points which are dissimilar, and we have put them together in the form of dissimilarity matrix. So what kind of data can be there in clustering analysis? We can have interval scale variables, we can have binary variables, we can have nominal, ordinal, and ratio variables, and we can also have variables of mixed type. Interval valued variables. Let's see what is interval value variables. So there are interval value variables. So we need to standardize the data. So we can first calculate the mean absolute deviation, which is calculated in the form of SF equals to 1 by n x1f minus mf x2f minus mf. So you can see mf is common in all this. So this is the median point, and we need to find the distance between each of those inputs with the median points, and then mod it and then divide it by n, summation of it divided by n, where the mf is, again, as I mentioned, it is the middle part of the frequency. So the summation of all this 1 to n frequency divided by n. So we need to calculate the standard measurement, that is a z-score, which is in the form of zf, which is equals to xif minus mf by sf. So this is how we calculate we try to find out the standardized form of data. So you are using the mean absolute deviation. It is more robust than using the standard deviation. It is much more preferred. Similarity and dissimilarity between objects. So as I mentioned, there can be some similarities and dissimilarities. We can see distances. What are distances in general? So distances are normally used to measure dissimilarity or dissimilarity. So either 2 points can be very close to each other, so they can be put in the similar cluster, or if they are very distant from each other, they will be put in different clusters. So you can see, first we need to calculate the distance between 2 points, dij. So this is how we calculate it. So you can see the formula. of this xi minus xj, one to one data. Then again xi2 minus xj2, second point to second point, and then like this correspondingly we can continue. We have to do the root of this to find out the distance. So some popular ones include, there are some different kind of research which has been done, and they have also calculated that the Minkowski distance, where also we have found that we can calculate the dij, the distance between 2 points, which is based on xi1 minus xj1, xi2 minus xj2, and so on. We can continue. So where all these points you can see xi1, xi2, xp, the second part j, which is having the second cluster. So this is the first cluster in the second cluster. So points in first cluster, points in second cluster are two p-dimensional data objects, and q is positive integer. So if q is 1, d is Manhattan distance. So this is how it is calculated. Similarly, we can have the second part where if q is equal